Lotus effect in nanotechnology. Hello viewers, I feel happy to meet you all through my YouTube channel Treasure Truths in Physics. Don't forget to subscribe this channel, my dear viewers. Come on, let's get into the video. This video deals about Lotus effect in nanotechnology. Before discussing what is Lotus effect, one must know the size of water molecule and water droplet. You know very well that water molecule consists of two hydrogen atoms and one oxygen atom. The bond length between oxygen and hydrogen atoms is 95.84 picometer. Imagine how smaller it is. 1 picometer is equal to 10 to the power of minus 12 meter. Very smaller than nano. The size of a water molecule is 2.75 angstrom, which is equal to 275 picometer. Group of water molecules combined together forms water cluster. The size of raindrop typically ranges from 0.5 millimeter to 4 millimeter. Theoretically possible largest drop is 10 millimeter. Experimentally observed largest drop is 8.8 millimeter. There are 20 drops in 1 milliliter of water. Therefore, 1 drop measures 0.05 milliliter of water, and this 0.05 milliliter is the average volume of a water drop. In a water drop, there are 1.5 sextillion of water molecules and more than 5 sextillion atoms. 1 sextillion is equal to 10 to the power of 21. It is quite easier to insert objects of smaller cross-section or smaller size into the hollow objects of larger cross-section or larger size, but it is impossible to do the same in a reverse way. Root hairs cells or outgrowths at the tip of the plant's roots. Root hair cells vary between 15 to 17 micrometer in diameter and 80 to 1500 micrometer in length. Xylem and phloem are complex vascular tissues that facilitate the transportation of water, minerals and food throughout the plant. Xylem carries water and minerals from the roots to the leaves, whereas phloem carries the food prepared by the leaves to different parts of the plant. The size of xylem vessel is 80 micrometer. Water molecules from root hairs are transported all over the plant through this vascular tissue, xylem. Stomate, also called stoma, is a pore found in the epidermis of leaves, stems and other organs that controls the rate of gas exchange. Its size varies from 19.1 micrometer to 71.5 micrometer. Air enters the plant through these openings by gaseous diffusion, that is through open stoma, and contains carbon dioxide which is used in photosynthesis. Oxygen produced as a byproduct of photosynthesis diffuses out to the atmosphere through these same openings. Also, water vapor diffuses through the stomata into the atmosphere in a process called transpiration. This moment, the stoma is called as closed stoma. The molecules like carbon dioxide, water and oxygen, which are of in smaller size, say 0.33 nanometer, 275 picometer and 152 picometer respectively can diffuse through the openings of cells which are of greater in size. What is hydrophobic effect? Hydro means water. Phobic means fear. Fear to water is called hydrophobic effect. Though hydrophobic effect is also called as Lotus effect, it is also observed in the leaves of other plants. Lotus effect refers to self-cleaning properties that are a result of ultra-hydrophobicity as exhibited by the leaves of Nilambo or lotus flower. Before we dive in detail into the Lotus effect, it is important to have an understanding of a concept called surface energy. Imagine there is an infinite array of atoms bonded together, an infinitely large piece of material. If we cut a shape out of this material, we would be creating a surface, and in creating a surface, we would have to break bonds between atoms. The energy required to break the bonds is known as surface energy. The high surface tension of water causes droplets to assume a nearly spherical shape, and this shape minimizes the solid liquid surface energy. The ways in which water droplet reduces its surface area or interfacial interaction with another material, process of wetting. Either complete or incomplete wetting may occur depending on the structure of the surface and the fluid tension of the droplet. Ever wonder what makes the surface of lotus leaf water repellent? The surface of the lotus leaf has a hierarchically rough structure which discourages wetting. The tubules are made of a wax that contains non-polar methyl groups. This non-polar wax doesn't favor interactions with water. A waxy non-polar coating and rough structure which both make surface interactions less favorable, allowing water to bead up into spheres and easily roll off the leaf. There are two types of surfaces: hydrophobic surface, hydrophilic surface. In hydrophobic surface, the contact angle is greater than 90 degree, that is high, where the adhesiveness and wettability are very poor. In hydrophilic surface, the contact angle is lesser than 90 degree, that is low. Contact angle is the angle between the surface and the water drop, which is greater for the hydrophobic surface. A self-cleaning surface is any surface with the ability to readily remove any dirt or bacteria on it. This concept is inspired from the lotus leaves, where dirt particles are picked up by water droplets due to the micro and nanoscopic architecture on the surface, which minimizes the droplets adhesion to that surface. There are basically two different types of self-cleaning coatings: hydrophilic and hydrophobic coats. The Lotus effect is achieved with the hydrophobic coating, which have high water contact angles above 90 degrees. Superhydrophobic coating have a water contact angle of greater than 150 degree. The water droplets from such surfaces form a spherical shape and roll away from the surface, carrying all the dirt away. Nanoparticles used in the coating have a large surface area to volume ratio and possess high surface energy. This has led to extensive research and growth in the use of nanotechnology. Today, there are textiles that repel not just water and dirt, but also keep wine and coffee stains, bacteria and odor away. Hydrophobic nano coating for shoes protect the coated fiber material against the rain, dirt, snow or even salts. It works like an invisible shield which is formed of billions of nanoparticles. The distance between the particles is so tiny that large molecules of water and mud can't anchor on the shoe surface or somehow interact with the coating layer. Ultra-hydrophobic coating turns scars into anti-scratch, anti-UV damage and self-cleaning. The hydrophobicity causes the particles of contamination such as grease and oil, limescale and materials from environmental pollution to adhere less to the substrates or allow them to be easily removed from the coating surfaces, that is, without applying abrasive agents. Nano liquid screen protector can guard the mobile phones from scratches and cracks. It improves the hardness of the screen. Screen protector both hydrophobic and oleophobic, repelling oil and other liquids. Fingerprints and dust are easily removable. Nano swimwear, which includes a plasma layer enhanced by nanotechnology to repel water molecules, is designed to help the swimmer glide through the water easily. More than 141 billion liters of water are used just to flush toilets each day, with millions of people around the world affected by water scarcity at the same time. According to the Penn State team, its coating can reduce the amount of water required to flush a toilet cleanly by 50% from 6 liters to just 3 liters. This team has developed a robust bio-inspired liquid, sludge and bacteria repellent coating that can essentially make a toilet self-cleaning known as LESS, liquid entrenched smooth surface. Thank you for watching this video. Expect your valuable comments. Don't forget to like, subscribe and share.